This video is going to go over complementary and supplementary angles, and I know you guys just super duper love math, so that's why I drew a heart around it today. The definition for complementary and supplementary angles, it's pretty easy to tell which one is which. So complementary, you could say that also represents, it makes the shape of a corner. And a perfect corner is 90 degrees. So that's one way you might think about. Complementary starts with C, corner starts with C, a perfect corner is 90 degrees. Supplementary starts with S, a supplementary angle makes a straight line, so they both start with S, and then a straight line equals 180 degrees. If I zoom in really close, another thing that sometimes people do, I'm going to take my pen, if I trace over this letter C, and then I look at part of the number 9 for 90, I could put a C on that. So complementary has a C, 90, I could form a C in the number 90. Then if I do the same thing, I could come over to S for supplementary. If I zoom in super close, I can trace over the S in supplementary. Again, straight also starts with an S. But if I trace over the 8, I could form an S inside the number 8. So that's one way that some people might find a fun way to do the 90 and the 180. Here's some examples, and we're going to find out the value of just the letter Q, or we could find out the value of the entire angle. So when you look at this overall shape, this one is making a straight line. So that means that this is a supplementary relationship, and they equal 180 degrees. Okay, and the thing I'm talking about is this bottom part of the angle where the two are joined together makes the straight line. I would just put the two angles together. So the first angle, oops, go back to pen. The first angle is 3Q plus the second angle is 15Q plus 18. And since it's a supplementary relationship, that equals 180 degrees. Then I would combine the things that are alike, combine like terms. So these two letter Q's can be together. 15Q and 3Q makes 18Q. And then the number 18 doesn't have anything to combine with it right now, so I would just leave it alone. And the whole thing still equals 180 degrees. Now it's ready to solve like a normal equation. I could draw my line down. And then the opposite of positive 18 is negative 18. I can bring down my 18Q that's over here. And then 180 minus 18 is 162. I'm going to scoot this over so I can have a little bit more space on the side because I wrote too big. The last step is to divide by 18 because that's the number with the variable. When you divide 162 by 18, you actually get 9. Okay, then I could come over here if I need to find the value of this angle right here. I would do 3 times 9, so that's 27 degrees. And then this angle, I would do 15 times 9 plus 18. 15 times 9 is 135. Then I would add 18, and then altogether that makes 153. If I zoom over here, this angle is 153 degrees. This next diagram below it makes a perfect corner, plus it has the right angle box. So I'm going to write in, this one is a corner, which equals 90 degrees. It's also an example of complementary. Okay, it shows you that this first angle is 2x and the second angle is 3x plus 15. So when I put my equation together, I'm going to use the value of the first angle and the second angle together. But at the end, this time I'm going to say equals 90, not 180, because I have this perfect corner. So here's how it would look as my equation. I'm going to zoom in so that I write a little bit better this time. First angle, remember, is 2x. Plus the second angle was 3x plus 15. And then it's a perfect corner or it's complementary, so I'm going to say equals 90. Now I would start combining the like terms. So these two numbers that have variables, they can go together. 2x plus 3x makes 5x. And then the 15 doesn't have anything with it, so it's just going to stay by itself. I would say plus 15. And the total of a complementary angle is 90 degrees. Now it's set up and I can solve just like a normal equation. I would need to isolate the variables, so I need to get rid of this constant number of 15. So positive 15, the opposite is negative 15. Once I do that, I can then bring down the 5x. The 15 cancels out, and 90 minus 15 is 75. Then final step is divide by the number with the variable. 75 divided by 5, then I would say the value of x is 15. So that's my first answer. The value of x is 15. Then I would come back over here onto my angles, and x is 15. So this first one, I would say 2 times 15. That means this angle is 30 degrees right here. And the next angle, this one, I would do 3, and instead of x, I do my 15. So 3 times 15 plus 15. 3 times 15 is 45. 45 plus 15 is 60. So the second angle is 60 degrees, and then I could look together, 30 and 60 do make my 90 degrees. So then I'll just put this back in perspective. Okay, the last thing we're going to do is just look real quick at this foldable. The tabs, this first flap is going to be complementary. The second flap is going to be supplementary. The fourth flap is going to say adjacent. And the last flap is going to say vertical. Whoops. Okay, so different types of angle relationships, and we're going to look inside. When you open up the first flap, it says angle WXY is complementary, and the reason that it's complementary is because it makes this right angle. So complementary. Together they form 90 degrees. Then on the bottom, the blanks, it says two angles whose measures have a sum of 90 degrees is the example. And then below, there's an example of how to do that one. The second flap is the one that said supplementary. So it says angle HIJ. So HIJ is supplementary to JIK. I'm going to write supplementary. In this one, it's going to say two angles are supplementary if their measures have a sum of 180 degrees. And then there's an example at the bottom. The third flap is one we haven't talked about yet, so I'm going to spend a little bit more time on this one. It says angle ACB, so ACB and ACD, they are adjacent. Okay, adjacent means that they are next to each other or they're side by side. These two specific ones are supplementary because they do make a straight line, but not always is that the case. So I'm going to leave that off because it's not always true. Two angles that are side by side. They also have a common vertex. A vertex is just this point in the middle. And they also have a common ray. So they share one line in common. So right here, the A to the center is the one that's in common with ACD and ACB. This line separates them. And then on the bottom, it says they may or may not be congruent. Then the fourth flap was vertical. And for this one, vertical angles are always congruent. So, for example, this has a 40 and this has a 40. When you have a grouping of four angles made by two intersecting lines, the vertical angles are congruent to each other. So on this one, I'm going to put congruent right here. And then at the bottom, it's going to say two angles formed by two intersecting lines. They are always, always, always congruent. Or they have the same angle measurement. Okay, so down at the bottom, this angle Y its vertical angle is over here, so they're the same amount. They're both 65. And then angle X up top, its vertical angle is the one that's like opposite of it. So its measurement is 115 because it's congruent to that other spot.